Hello everyone. So in the last video we saw one formula for the potential difference or the electric potential, which came out as V equal to W by Q. So voltage is equal to work done by the charge. There we got 1 volt is equal to 1 joule by 1 coulomb. So today we'll move on to one very important topic, that is the Ohm's law. Ohm's law. So till now in this chapter, as I told, we have learned about current I, we have learned about the charge C, charge Q, and we have learned about V, voltage or potential difference. So using all these three, we will get one more unit to learn, very important topic to be covered, that is our Ohm's law. So Ohm's law is a very important law in physics or in electricity for the proper applications of electrical appliances or for the electrical appliances. This law is related with the voltage and current. This law has a direct relation with voltage and current flowing through a circuit. So according to this law, it states that the total amount of voltage in a circuit is directly proportional to the current flowing through it. That means if in a circuit there is some voltage, means if the circuit is connected to any external output or any external source of power, then there will be some voltage in the circuit, and that voltage will be depending on the current, how much current will be flowing through the circuit. If more current is flowing through the circuit, then the circuit will have a higher amount of voltage. If less current is flowing through the circuit, then it will have a lower amount of voltage. It is the Ohm's law is the basic governing law for most of the or every electrical appliances or electrical objects that we use today. So I am just giving the definition here. It states that the voltage in a circuit is directly proportional to the current flowing through it. Means the current flowing through the circuit. So using this statement, we get V directly proportional to I. V is proportional to I. That means if V increases, the value of I, that is current, will also increase. If V decreases, the value of current will also decrease. Now, if you see here, there is a new symbol. This is the symbol of this is a proportionality constant. This is a proportional symbol, and whenever this symbol is there, we cannot go to a final conclusion. Like if you are solving any numerical, if you are doing some numerical calculations, we cannot go or reach to any final conclusion if we have this symbol in there. We can only solve any equation or any calculation only if there is an equal sign. So we need to remove this proportionality constant. This is a proportional symbol, so we need to remove it. So this symbol is removed by this component R, and R is known as the resistance of any conductor. R is the resistance. And here in this case R is the proportionality constant. In this case I am writing for this case only. This is constant. Now this symbol, this word or resistance is a new term to you. Now first of all, what is a resistance? Resistance is the ability of any conductor to oppose the flow of electrons. We know electrons flow through every conductor. If the matter is a conductor, if the material is a conductor, then it will conduct electricity. That means it will allow the electrons to flow through it. And the flow of electrons give us current, and through current we get the electricity. Now, as we know, inside every conductor, every matter, every material, inside those there are atoms. And these atoms provide some resistance or some opposition to the flow of the electrons. And this opposition offered by the materials is known as resistance. In metals, the resistance is less, so electrons can flow easily and hence it can conduct electricity. But in non-metals like this duster, like this wood, the resistance or the opposition to the flow of electrons is very high. So what happens when this means through these metals or through these objects, through the wood, electricity cannot pass. If I connect one point of wire here, live wire here, current will not come to this side because it is a bad conductor of electricity. Now in conductors, every conductor has a different resistivity value, means ability to stop the or block the flow of electrons. We will learn this one in the upcoming topics. So just you have to understand the resistance, and for this topic, resistance is the ability of any conductor to oppose the flow of electrons. And this formula can be properly written as V equal to I R. This is our formula for the Ohm's law. This is our formula for Ohm's law. You can write it down. Now here in the Ohm's law, we got to learn about the relation between voltage and current and how this relation can change because of the resistance or resistivity of the conductor. As we know, metals are good conductor of electricity, so electricity will flow through them. But you might have noticed, like in our homes, if someone when there is some electric circuit, some wires, mostly people prefer the wires made up of copper over aluminium. We can find different types of wires like aluminium wires or copper wires, but we prefer mostly the copper wire, because through copper, electrons or electricity or current can flow in a more proper way. So that depends on the resistance. Of that material, that means copper. We'll learn about this in the upcoming topics. So for this, just this one is important. Thank you.